Hello class, this is Dr. Mike. We're going to talk about data analysis process this week. So far in the course, we've built up your skills with Python. We looked at basic Python itself. You've explored importing data and leveraging libraries such as pandas and matplotlib. Now we come to a point where we need to actually look at a larger picture of how you do the data analysis process. So it's important to have a process in place. We definitely want to show that when we be able to document and show we have integrity in our process, there's no bias. Also the quality of the data itself. So a larger part of doing data analysis is just documenting the process and the source of data that you used. So whether you like it or not, statistics is going to be a huge part of this. And it's going to help, your process will help you point to what statistics you should be using for the data you've collected. So here's a quote from statistician John Turkey. Procedures for analyzing data, techniques for interpreting the results of such procedures, ways of planning the gathering of the data to make analysis easier, more precise or more accurate, and all the machinery and the results of statistics used which applied to the analyzing data. So that's his definition of data analysis process. There's probably several others out there, but I like this one. It's pretty good. So here's from Kathy O'Neill and Rachel Schutt, data science process flowchart. There's all kinds of models out there, but it's important to see you either collect raw data or your data has come pre-processed. So this step itself here, this could be either done for you. You may have gotten data that's already been processed and even cleaned, but it's important to explore the data itself. So there's some exploratory data, and then figuring out your model, your algorithm you might use. These could be very simple ones. It could be to answer a question: what's the average price? How much are we selling on average of beer, let's say at a baseball game, when the team's winning versus when our team's losing? So these come from business. Could be business questions in nature. They could be scientific. And of course, we have our product, which could actually lead to more data. So you could actually have more questions come out of your data analysis. In any case, you should hopefully have some answers you can communicate or visualize. And you can use this data itself in further research. So the process itself, we want to look at the requirements. We want to know our collection process, how we're going to process and clean the data or verify it's clean. We'll talk about that in a second, what that really means. The exploration of the data itself. We need to understand our actual data. Its averages, does it have certain aspects that require certain types of processing? A modeling, if we want to use any kind of type of pre-existing models, and of course our product that comes out of it, and how we're going to communicate this. So again, we've been looking at building up answering questions, and that's really what it's going to be about. How do we communicate the answers to the questions that were posed? And those come back out of step one, requirements. So again, you could take this as the owner of a baseball team says, do we sell more beer when our home team wins and during home games, or when we have a losing season? And so we can determine by this, well, we need to go and collect our sales data and also our data of wins and losses at home games for several seasons. So this could be, we want to do more than just maybe 2 or 3 games. We want a larger collection of data. Normally in any kind of data analysis, the larger data set you have, the better. There could be errors introduced if you have very little data. And of course, we want to bring that data in and process it, ensure there's no errors, and then we want to explore it. What does it look like before we actually go in and plug it into some models and come out with our answers? So again, what is the questions need to be answered? Yeah, it's important to make sure that we collect the right data to answer the questions correctly. And then what is the nature of the data we're going to collect? Is it numerical, categorical? Is it a Boolean of nature? Is it qualitative in nature, or quantitative? So quantitative, very important. Let's say it could be measured, like a temperature. Could be a sales in dollars. Quantitative, might it be actually measured? We have maybe survey data from customers. So more about, it can't be measured accurately, but we do still have an actual measure in place. And of course, how much is needed? We need statistical significance. Very important we have this. Some of the old models would say 30 observations or more. You want the most data you can get. Very important we have that. So we actually collect the data. Now this could be collected directly from us. Let's say, again, maybe it's data we have in place. Let's go back to the baseball team example. You have the till counts. You have from the accounting department of beer sales, and then you also have, of course, the official records of wins and losses for home games. So those can be easily gathered. Or it could be, and maybe we need to actually create a measurement tool. It might need to be a survey to our fans, needs to go out, or it could be pulled from existing data. So, example, U.S. Census data. Maybe we have questions about population information, or it could be we actually need to canvass the neighborhood with actual questionnaires to collect it. So, in any case, we need to be sure you document the source of the data and how it was collected. If it comes from a central source, document the location. It could be the website. It could be the direct link to the data. And if not, document the process, the questionnaire you actually used. So just don't say the results of the questionnaire was, everyone was rated our team of 4 out of 1 to 5, 1 being low and 5 being great. Actually want to show the questionnaires that were used and actually have the raw data that was collected. It's important because you want to be able to give this data to someone else for any reason to do independent analysis. So any data processing. So this could be, maybe if the data was collected online with a survey, we might need to parse the data. Example, if it's an XML, maybe get that to a table format. So now we leverage our skills with importing data. So like we've seen in previous lessons, we want to bring the data in. And if at all possible, keep the original data set also. So as we've seen with Jupyter Notebook, we can create a cell to import the data raw from let's say a CSV file. We want to keep that CSV file intact and then maybe create a dictionary, or let's say a pandas data frame by a different name. So we can always go back to the original format. And actually any post-processing, maybe I take that pandas data frame and I'm going to make some calculations on it. Maybe I won't overwrite the original data frame. I'll actually create maybe data frame 2. And that way I can always go back and see every step I've completed. Again, this is the power we have with Jupyter Notebook. And very important, again, with Jupyter Notebook, we can actually document the process right in Jupyter. We can state your assumptions, state why we did this process. It's important to do it as soon as possible. If you try to go back and read a Jupyter Notebook that has no comments, it can be hard to interpret why certain steps were taken. So documenting that within the notebook itself can be very handy. And part of this too could be we need to look for errors or duplicates. So we can definitely do these checks very easily with Pandas and Matplotlib and other tools we have in both Jupyter and Python. And we want to state how we handle those. So again, we want to document how we handle errors. So maybe we were looking at a data set of continuous data of measurements, and there were some errors. And so we either drop the error records or we put in the average for that time. So whatever reason why, and whatever method you use, you want to document how we handle that. Same with duplicates. Most time you may want to drop duplicates, and you want to say how you determine it was a duplicate record. It could be a date timestamp, it could be an account number, or whatever reason. So it's important to again document how we handle this. Then we want to explore the data. So before we just plug it into a model, we need to explore what we're looking at, understand the data itself, and let's just do some distributions. Let's look at the min, max, medium, and means. This is very easy. We see this with like matplotlib, for example. Very easy to go ahead and even pandas to get this data really quick. And we're looking for distributions. How does our data look? Again, I don't want to get in too deep into statistics here, but let's look at normality of our data set. Is it skewed? Is it got kurtosis? And visualization here could be very handy. And we want that bell curve. We get that bell curve, we can look at it. We want, at best possible, we want a normal distribution. But again, we want to document our results. It could be this is our data, we have to use it. But we want to know these factors before we go into our next step. So again, go back to our Jupyter notebook, and let's document what we saw and our interpretation of it. So now we bring in some models. So there are plenty of models out there, and this is where you can definitely get very deep in data modeling. But let's for real simple ones here. Let's look at some, besides mathematical algorithms, probably the most common statistical method is our correlation and causation method. So example, again, so back to the baseball, does have a winning season at home games increase our beer sales? So that's a pretty valid business question. So is there a correlation between wins and the number and the money we got from beer sales, so the amount of beer that was sold? So we want to use, again, Pandas has several libraries here, and there are other libraries too that actually help you both get numerical and visual results, so we can see these correlations. We want to generate our results, again, both visual and tabular, and also put in your interpretations too. We want to infer our answers from the questions. So it's important we go back and reiterate the question that was asked, and then show how we inferred the answer from the data itself. So again, here's our example with the winning teams. These results could be used for further analysis. So we see that showing that beer sales were higher when home teams were winning. We might have other questions. So you could actually perform some post-analysis. Let's say, example, what were the top 5 beers that were sold? If we have that data. This might help answer additional questions that might come up. Or you might be able to have to do this after the fact. You could pose, yes, we sell more beer when home teams are winning, and they might come back and say, well, what's the most beer that sold? So if, again, we can go back and look at our previous analysis and determine, yeah, we can derive this value. We can figure out the top 5 beers. This might help when we order beers in the future. Other things too, again, what was the average spent on the beer and so on. So there's could be several questions and actually further results. So you can want to document all results that you inferred. So again, you might have something that does more than answer the question. And this can be very helpful and actually very pleasing. You might have show more information that was initially asked. And of course, how are you going to report this? So think about your audience. If you're talking to another data analysis, data scientist, you might have a different type of report. So even though it's important to have all of those details in our Jupyter notebook or somewhere documented about how we handle errors, we don't need to report that depending upon the audience. If it's a group of business folks, again, let's go back to our example with the baseball stadium. They probably don't need to know what kurtosis is or normal distributions. So you might have more of an executive summary. And this might be right within your Jupyter notebook, or this could be within a presentation. Very possibly you might have a few points here. So later on in the course, learning to give good, clear presentations is very important. Also, clear reports. It's possible you might have more than one report. You might have the summary report that will be handed to the executives, and you might have more of a detailed report. Give them all the greedy details in the math. That might go to other data scientists for further analysis. And so that's it for data analysis. It's important to understand these steps, the process, as we mature your skills with data analysis. It's good to go and look at this large overview, and it helps you become a better data scientist. Thank you.